Hey there, everyone. It's Mr. Lamb coming to you with the 4344 extra practice. As I said today in class, I'm not going to actually show the calculation in the calculator. I'm just going to get it all set up. I'll tell you what you should be typing into the calculator, and then I'll give you the answers to each one of these. So let's take a look at the 4344 practice. In these first four problems, all kind of set up the same way. Identify your angle first, and then list your sides as either hypotenuse, opposite, or adjacent. So list your H, O, and A. So the hypotenuse here is going to be C, opposite will be X, and adjacent will be 13. And then I'm going to decide which one is useless. So the opposite side has an X, the adjacent side has a 13, but the hypotenuse here has no markings. It doesn't tell us a length, it doesn't tell us anything about it. So I can actually get rid of that one. And what I'm looking at is SOHCAHTOA. So SOHCAHTOA. All right. So SOHCAHTOA is what I'm kind of taking a look at here. So opposite and adjacent, so that means I'm going to do the tangent. So the tangent of the angle, so tangent of 32 is equal to the opposite side over the adjacent side. So the opposite side is X, the adjacent side is 13. So in order to solve for X, I would have to multiply both sides by 13, because on the right side of the equation, you can see X divided by 13. So if I multiply both sides by 13, I will get 13 times the tangent of 32 equals X, because the 13s will cancel one another. So in your calculator, you'll type in 1/3 tangent of 32. I will round everything to a 1 decimal point. You should get approximately 8.1. Number 2, here's my angle 60. So AC is my opposite, X is adjacent, 11 is the hypotenuse. So which one do I know nothing about? I know nothing about the opposite side. So A and H is going to be cosine. Cosine of the angle. Cosine of 60 is equal to adjacent over hypotenuse. So X over 11. Again, that's X divided by 11. So I'll multiply both sides by 11. So X is equal to 11 times the cosine of 60. That's what goes into the calculator. Type in 11 times cosine of 60, and you should get about 5.5. I don't even know if that's about, I think that may be exactly 5.5. Okay, let me pull down the SOHCAHTOA thing. Number 3, here's my angle. So this is opposite, hypotenuse, adjacent. So which one am I not using? I'm not using the hypotenuse. So I have opposite and adjacent. O and A is tangent. So the tangent of 50.1 equals the opposite X over the adjacent 5. So that means X, multiply both sides by 5. 5 times the tangent of 50.1. Calculate that out. You end up rounded. It rounds to about 6.0. I think it's 5.9 something, 5.97 or 5.98. Rounded, it rounds to almost 6.0. Number 4, here's my angle. So hypotenuse, opposite, and adjacent. Which one is useless? I don't know anything about adjacent, so that'll be the one that goes away. O and H is sine. So the sine of the angle, 37, is equal to the opposite X over the hypotenuse, 10.3. That's X divided by 10.3, so again, I multiply both sides by 10.3. So 10.3 times the sine of 37 is equal to the X value. And in this case, rounded, X should be about 6.2. about 6.2. So the first four, all very, very similar. Set up the trig function and you end up multiplying on both sides. All right, let me jump down here now to 5, 6, 7, and 8. These are all very similar in the fact that I'm looking for an angle. So in this case, I'm going to use all of my inverse functions. So inverse sine, that's the sine with the -1, or cosine with -1, or tangent with -1. I will use those anytime I'm trying to find an angle. So if this is my angle, I have my opposite, hypotenuse, adjacent. Which one is useless? The h is useless. I don't know anything about it. So O and A, so that is tangent. So the tangent of the angle, theta, that's the Greek letter theta, is equal to the opposite over the adjacent. So 4/13. Now, when I say solve for theta, and you decide what is it that has to go, you have to get rid of the tangent. So you may do that. So theta can equal, if I want to get rid of tangent, I have to do the tangent -1, inverse tangent. On your calculator, it is the second button, then tangent. And then I would type in 4/13. That's what goes into the calculator. Inverse tangent 4/13. That means theta, and it says we want to round this still. So these are all degree measures. So this is going to be roughly 17.1 degrees. All right, number 6, here's my angle. So this is opposite, adjacent, hypotenuse. Which one is useless? I don't know anything about opposite. So I have A and H, that's cosine. So the cosine of the angle, so cosine of theta, is equal to adjacent 4/hypotenuse 5. So I need to get rid of cosine. So I use inverse cosine, cosine with the -1. And then I'll put in 4/5. Type that right into your calculator. If you don't know where your fraction button is, just do 4 divided by 5. That's where your fraction button is. 36.9 is what I got here. 36.9 degrees. Number 7. As I take a look at number 7, we have my angle. So opposite, adjacent, hypotenuse. Find the one that is useless. I don't use the h at all. I'll get rid of that one. O and A means it's tangent. So again, tangent of the angle, theta, is equal to opposite, 3/adjacent, also 3. So to solve for theta, I have to get rid of tangent. So theta equals tangent -1, called the inverse tangent, of 3/3, which is 45 degrees. That is 45 degrees. And the last one. Here's theta, hypotenuse, opposite, adjacent. The useless one is opposite this time, so A and H, cosine of theta is equal to adjacent 6/hypotenuse 9. To find theta, I have to get rid of cosine. So inverse cosine, 6/9. So the inverse cosine of 6/9 is 48.2 degrees. I'm going to keep rolling right into page 2 if you don't mind. Number 9 says an airplane takes off 200 yards in front of a 60-foot building. So hopefully you noticed right away that I have this little discrepancy of I have 2 different units going on here. So I'm going to change my units. One of the things you need to know, 3 feet equals 1 yard. So 60 feet would be 20 yards. I want to change that 60 feet and change that 60 feet to 20 yards. All right, now it's all in yards. And now I'm going to take a look at my triangle. So here's my angle. So this is my opposite, hypotenuse, adjacent. I know the opposite side is 20. I know the adjacent side is 200. I don't know anything about the hypotenuse. So I'll get rid of hypotenuse. So O and A is tangent. So the tangent of the degree measure, which they said is x, is equal to the opposite, 20 over the adjacent, 200. So to solve for x, I have to get rid of tangent. I get rid of tangent with inverse tangent, so tangent to the -1. And then in there, I do 20 over 200. And if you type that into your calculator, you should end up with about 5.7. Now, what have I measured? 5.7 is equal to x. X is a degree measure. It is in degrees. So I can label that in degrees. Okay, number 10. One of the things that I have found is I will draw my triangles one of two ways. You'll either see me draw my triangle like this, or like this. And it's going to be based on if I want an angle of elevation, I'll draw the one on the left. If I want an angle of depression, I'll draw the triangle on the right. So, I want to read the problem. Brian's kite's flying out of above a field at the end of a 65 meter, at the end of 65 meters of string. The angle of elevation. So because of that reason, I'll draw my triangle this way. So Brian is down here. His kite is up here. And it says that the string that's connecting Brian to the kite is 65 meters. The angle of elevation, here's an angle of elevation, is 70 degrees. And it says that Brian is holding the kite above the ground. All right, so here's the ground. So this point over here on this end, down to the ground, is 1.2 meters. It wants to know the height of the kite. So it wants to know what is this big distance here. Well, this big distance is going to be the 1.2 meters off the ground plus whatever that x value is. So I have to find x. So in order to find this height, I have to find x and then add the 1.2 meters that Brian is standing onto. All right, so let's just look at the black triangle now. So I have my angle 70. This is opposite, hypotenuse, and adjacent. I know that the opposite side is x, the hypotenuse is 65. The adjacent side I don't know, so I'm going to get rid of adjacent. So O and H is sine. So the sine of the angle, 70, is equal to the opposite, x over the hypotenuse, 65. In order to solve for x, multiply both sides by 65. So x is equal to 65 times the sine of 70. But if you type that straight into a calculator at 65 times the sine of 70, you will get 61.1. But that is not my answer. 61.1 is just the distance. If you look at the triangle, it's just the distance from the blue dot to the blue dot. That is 61.1. I want to know the total height of this thing. So the total height, as we talked about earlier, is the height from blue dot to blue dot, so the 61.1 plus the height that the kite is in the air because of Brian holding it, the 1.2, I add the two together, and I get 62.3, and that is measured in feet above the ground. You will see a lot of problems that have that little concept of the triangle has already been shifted up in the air so far. You see that quite a bit. That is a very common problem technique. Number 11, if the distance from a helicopter to a tower is 300 feet and the angle of depression. That's going to just tell me how I'm going to draw my triangle. I'm going to draw my triangle upside down. So I have an angle of depression. Okay, so up here is my helicopter, and down here is my tower. It says, if the distance that a helicopter, from a helicopter to the tower is 300. So that's 300. Angle of depression is 40.2. Find the distance on the ground. Okay, so that would be from directly below the helicopter to the base of the tower. So this is the distance that I want to find, that X. Well, I can see for my triangle's sake that the X in green and the now X up on top in black would be the same X value. So that's what I'm looking for. All right, let's get to the trig. So there's my angle. So this is opposite, adjacent, hypotenuse. Which one am I not messing with? I'm not messing with opposite. It has nothing. It's useless for me. So A and H is cosine. So the cosine of the angle, 40.2, is equal to the adjacent X over top of the hypotenuse, 300. Solve for X. In order to get X by itself, multiply both sides by 300. So 300 times the cosine of 40.2 will equal the X value. Type that straight into the calculator. 300 times cosine of 40.2 is 229.1. So 229.1. And that is measured in feet. And final question, number 12. From a point 115 feet from the base of a redwood tree, the angle of elevation. Once I see angle of elevation, it's going to help me draw my triangle. So again, angle of elevation, my triangle will face this way. All right, from a point 115 feet from the base of a redwood tree. So we're talking about a horizontal distance. The angle of elevation is 64.3. Find the height of the tree. So we'll call this T for tree. So as I think about trig, my angle, so I have opposite, hypotenuse, and adjacent. Find the one that is not useful. So the hypotenuse will not help us here. So O and A is tangent. So the tangent of 64.3 is equal to the opposite, T, over the adjacent, 115. To get T by itself, multiply both sides by 115. So 115 times the tangent of 64.3 is the height of the tree. Type that directly into the calculator, 115 times the tangent of 64.3, and you should get a height rounded to the nearest foot of 239 feet. Remember that there is not a quiz over this. This will just be showing up on the test. See you guys tomorrow.